Hello students, how are you? Hope you are doing well. Now the question is, monochromatic light of frequency 5 into 10 to the power 14 Hertz passes from air into a medium of a refractive index 1.5. Find the wavelength of the light reflected and refracted at the interface of the two media. So the problem is based on the topic light, and in this particular problem there are two concepts used. The first concept is that v equals to nu lambda, where v is the speed of light, nu is known as the frequency, and lambda is the wavelength of light. And the second concept or the second formula which is useful here is lambda medium is equal to lambda air divided by mu, where mu is the refractive index. On this particular problem, the situation is the light enters, the monochromatic light enters from air to some medium. Now what happens in this situation that some portion of the light it reflects, whereas some portion of the light it refracts. So both the processes takes place at the interface. At this particular interface, both the processes took place. The light reflects as well as the light refracts. The light refracts when it enters from a medium, that is air, to certain medium. So air is rarer as compared to the medium because the refractive index given is as 1.5. It means that the medium is denser. It means that the light is bent towards the normal. Now in this particular problem, when the light reflects, it is in the same medium. It is in the same medium. So we use this particular formula to calculate the wavelength of the light. So the wavelength of the light in air is v upon nu, where v is the speed of light and nu is the frequency of the light. So lambda is equal to v. V means the speed of light. The speed of light is 3 to 10 to the power 8 meter per second, and nu is the frequency, which is given as 5 into 10 to the power 14 hertz. So after putting these values, we get this answer as this is in meters, and suppose we want to calculate the wavelength in nanometers, then we have to multiply this particular ratio by 10 to the power 9. So after multiplying it by 10 to the power 9, the unit is nanometers. After solving this, we get the final result as 600 nanometers. So we can say that the wavelength of the light in air is 600 nanometers. And to calculate, this is the answer of the first part. This is the answer of the first part of the problem, that is the wavelength of the reflected light. And for the second part, the wavelength of the refracted light, we have to use this particular relation, that lambda is a medium. Lambda in medium, that is wavelength in a medium, is the ratio of wavelength in air and the refractive index. So this thing we have calculated, lambda air, wavelength in air, we have calculated as 600 nanometers, and mu is 1.5. So after solving this, we get the value as this comes out to be 400 nanometers. So we can say that the wavelength of the light, it changes to 400 nanometers. So this is the answer for the second part. So hope you understand the solution. Thank you.